Alright, welcome to the video for 12.3. We're talking about inscribed angles today. So we're going to be able to look at what the measure of an inscribed angle is, and then similarly when it's a tangent and a chord running into each other, same type of rule for that. So inscribed angles, alright? An angle whose vertex is on the circle and whose sides are the chords of the circle. So an inscribed angle has its vertex on the edge, and the sides of the angles are chords. Okay? When you have an inscribed angle, that inscribed angle is cutting off or intercepting part of the circle, so we get an intercepted arc. So there's a relationship between the blue arc and the red angle as far as their measure. So angles formed by intersecting lines have a special relationship. Alright, the measure of an inscribed angle, so the one I had in red, is 1/2 the measure of its intercepted arc. So the inscribed angle is half as big as the arc on the outside. So that means if I have a 60 on the outside, that means that this angle on the inside is half of that. It's divided by 2. It's 30. Okay, so the angle on the inside is half the arc on the outside. All right, so what we're going to get are a lot of problems that they're all using that one single idea. It's just a matter of trying to solve each of the puzzles here. So they want us to find the values of A and the values of B. So when I look at A, that's an arc. Okay, that arc that I have blue there. So I like to highlight that. That's going to be an arc, so that is twice as big as something. So if we kind of trace where the arc is being intercepted, we see that this A is twice as big as the the inscribed angle that makes it. So that means if this is a 60, all I need to do is double that. A has to be 120 degrees. Okay? Then we move on to look for B. All right, B is an inscribed angle. If I trace that, I can see that that's going to cut off an intercepted arc through A, and then including this 30. So if this is 120 and this is a 30, that means that total we have 150 degrees right there. All right, and I need to go from outside back inside. So I need to take half of that intercepted arc. All right. So if I'm working from the inside of the circle outward, I'm going to multiply by 2. If I'm going the opposite way, if I have the arc and I need the angle, I'm going to divide by 2. So B is 150 over 2, which is 75. Okay. In this one, they want to know what is the measure of angle A. Well, angle A is here. It is cutting off an entire semicircle. And if you remember, semicircles have 180 degrees. So if I need to go from outside to the inside, I'm going to divide by 2. So the measure of angle A is half of 180, which is 90. Okay. Down here, I have a quadrilateral inscribed in a circle, so I have 4 inscribed angles in this one. So with angle A, if I want to try to find that one first, that's this angle. I'm going to highlight it. That's going to go all the way from this 90 through this 100. So I'm looking at 190 degrees that I'm cutting in half. So that's what I'll do here. The measure of angle A is that 190 over 2, or 95 degrees. Okay, then I'll move on to angle B. Angle B is here. All right, that's going across a 90 and a 64 for a total of 154. So the measure of angle B is 154 over 2, or 77. Looking at angle C, it's going from here to here, cutting off this entire arc from 64 to 160, or a total of 170. So the measure of angle C is 170 over 2, or 85. And then lastly, I'll look at angle D, which goes from here to here across a 100 and a 106, so 206 total. The measure of angle D is 206 over 2, or 103 degrees. There's my answer for this chunk. Okay. The next part says, what do you notice about the sums of these opposite angles? Okay. The sums of the measures of the opposite angles. Well, that would be A plus B, which is going to be 95 plus 85, which equals 180 degrees. Okay, if I look at C plus D, then I'm talking about 77 plus 103, which is also 180 degrees. The sums of the measures of the opposite angles are supplementary. All right, which is true in some of the quadrilaterals we talked about in Chapter 6, but that's really what we're looking at right now. If you have a quadrilateral inside that circle, your opposite angles should make 180 degrees. So a couple corollaries, a couple ideas that will get us maybe some of these answers a little bit faster, just some rules that we can always follow. All right, if you notice that two inscribed angles, that if they intercept the same arc, then they have to be congruent. Okay? If they're cutting off that same piece, so if you look at A and cutting off that blue angle right here, okay, well, if you notice that B is actually cutting off that same arc, that means that these two angles have to be the same. An angle inscribed in a semicircle, that's just going to be 90 degrees. We're cutting off that entire half of the circle. This has to be a 90. Okay. And then lastly is the one we just had come up with, or just shown. If you have the opposite angles of a quadrilateral, they're going to be supplementary. Okay. So you can use some of those corollaries as we go, just maybe to make a couple things faster or more efficient. But that's really what we're going to look to do. This one says, what is the measure of each numbered angle? So for this one, we're just looking for the measure of angle 1. Okay. Always highlight that part. All right. Angle 1 is cutting off an entire semicircle. So we don't need to look at the 40 or the 70 in the picture at all. If you see that you're cutting off an entire semicircle, that means that you have a 90 for your inscribed angle. That's just corollary 1. Okay. For the second one, the measure of angle 2, here's going to be an example of corollary. Oh, I'm sorry, this is corollary 2, my mistake. All right, here's an example of corollary 1 right here. This is when you have two angles cutting off the same arc. So this piece right here, angle 2, is what we're looking for. It's cutting off the same arc as this 38. All right, so if they're cutting off the same arc, they have to be the same. So I know that these two angles have to be the same, or this has to be 38. In other words, I could double this one to 76 and then divide it right back down. You're going to end up with what you started with. This is going to be corollary 1 then. Okay, here's the corollary we didn't show yet. That's corollary 3. All right, what is the measure of each numbered angle? They're looking for angles 1 through 4. With these ones, feel free to look at whatever one is easiest first. You do not have to go in order at all. So one thing that I might notice right away is that angle 1 is one of the easy ones. Since it's cutting off a semicircle, that has to be a 90. All right, same exact thing with 3, plus the opposite angles need to add up to 180. So angles 1 and 3 should both be a 90 this time, since they're both cutting off exactly half the circle. All right, then I can look at trying to figure out 4 and 2 in kind of either order. I see some more numbers across from 4, so I might start with 4, okay, and see that that is cutting off an entire arc of 140, 60 plus 80. I'm going to cut that in half, so I know that angle 4 is 70, which means that as we look for that last one, all we would really need to do is take 180 minus that 70 that we had just found, since the opposite angles have to add up to 180. So that would be our angle 2. Okay, last part of the notes here is sometimes it doesn't look quite the same. You don't have an inscribed angle, but you have something close to it. And that would be when you have a chord and a tangent running into each other. So again, a chord and a tangent. What happens when you have a chord and a tangent run into each other? You're still intercepting an arc that I'll make red here. And it's still going to be a situation where the arc is twice as big as the chord and the tangent. So it's still going to be this half the measure of the intercepted arc. So it's still twice as big on the outside than the angle on the inside. So here's an example of that. So with this one, and there's a few ways you can look at doing this one, a couple different orders of your steps. What we know is that PMQ is 212. What they want is the measure of PQR. They want this angle right there. So I know that PMQ is 212. That's this entire arc. So I can do this a couple different ways. If I knew this arc, I could divide it by 2 and get that angle. So I could get that arc by doing 360 minus 212. Okay, and getting 148. So I could say that that's 148. And then at that point, the measure of angle PQR is just 148 over 2, okay, or 74. Okay, just to show you that these have more than one path to get to the answer, we could do the same thing right away. We could divide by 2 right away. All right, so we could do the 212 divided by 2 and get 106, and then use the fact that we have a linear pair here at 180 minus that 106, giving us 74. So there's going to be a couple different ways or a couple different paths to the answer each time. It's just about finding one that works. Okay. This one says, what are the values of x and y? All right, so we need to look for those two things. With this one, we do have a triangle going on here. Let's see what is easiest to find first. So x is going to be this angle here, which is going to be half of an arc. So I can figure out the measure of this arc by taking the 35 and doubling. So this is a 70 right out here, okay? Which means that x is just going to be 70 divided by 2. Or in other words, we have those two angles, or inscribed angles, intercepting the same arc. So 35 degrees is going to be what happens when we cut that 70 in half. All right, for y, that's where I'm going to use this triangle here. What I notice is that the green angle here should be 90 since I'm cutting off this entire semicircle. And then I'm just going to use the fact that I have 180 degrees in my triangle minus 90 minus the 35, which would all add up to 180 since we have a triangle. And that should give me a total of 55 degrees for my y. Okay. Last one here, just a little bit of vocab to go with it. Which arc does angle A intersect? Well, we would just trace angle A and name the arc that gets intercepted. It looks like that might be a semicircle, so I might throw in 3 letters with that. Either arc DCB or arc BCD would be fine as well. Okay, which angle intercepts ABC? So I'm going to highlight ABC and then trace down to find which angle is making that. That would be angle D. All right, and then one last check of which angles should be supplementary. Those are the opposite ones. So this time it's A and C that should make 180, and then B and D. All right, so that's our lesson for 12.3 inscribed angles. All right, the angle on the inside is half as big as the arc on the outside. So that's going to be how we would find the measure of an inscribed angle and also the measure of an angle formed by a tangent and a chord. All right, good job. Go ahead and get to work.